In this video, we are talking about section 6.6 on the graphs of trig functions. So up until now, what we've been doing with trig functions is we've been plugging something in for the angle, and then we get out some value, and that value represents some ratio. We either got that ratio using SOHCAHTOA and our right triangles, or we got it using the unit circle. Okay, but because I am plugging something in and then getting something out, I can think of this function as a graph, and that's what I want to do now. So, okay, first, let's talk about the graph of y equals sine of theta, or I can write that as y equals sine of x, if I want to call that input angle x. So to get a feel for this graph, I'm going to plug in a few angles and then see what do I get out as my output. Okay, so to help me with this, I'm going to draw a quick sketch of our unit circle. So let's draw a quick sketch of a unit circle. Okay, and I got my axes, I got my circle, and I don't need every single relevant angle on the unit circle. I'm just going to plug in a few sample angles like 0 and pi over 2 and pi. So I know that angle 0 is over here at this right endpoint. I know that pi over 2, 90 degrees, that is up top. That's my angle pi over 2. Pi, another 90 degrees, that's at the 180 degree mark. That is over here. And then 3 pi over 2 is 270 degrees. That's down here. 3 pi over 2 is down there. And then 2 pi completes a full circle. So 2 pi is at the same spot on the unit circle that 0 is. And let's write the coordinates of those points. So I know where this angle 0 is. The coordinates are 1, 0. At pi over 2, it's 0, 1. At pi, it's now x is negative 1, and then comma 0. And then down here, x is 0, and my y coordinate's negative 1. Okay, so remember that sine is my y coordinate on the unit circle. So when my angle is 0, so I'm looking at the angle 0, I'm taking the y value of that point, which is 0. So my output is going to be 0 here. So that is what sine of 0 is. It is just 0. Okay, next up, I want to plug in pi over 2 for my angle. So I'm going to be asking myself, what is sine of pi over 2? All right, so I'm going to look at the angle pi over 2, and what are the coordinates there? And sine is the y value, and the y value of that point is 1. Okay, so I'm getting 1 as my output, as my y coordinate. Okay, so if I keep doing this, so the next angle is pi, and the y value at that angle is 0. All right, at 3 pi over 2, the y value is negative 1. So that's what sine of that's what sine of 3 pi over 2 is. It's negative 1. And then back to 2 pi now, the y value is 0 there. So sine of 2 pi is 0. Okay, so now I have a few inputs, and I know their outputs, so I can plot these points. So on my axes here, I've already labeled some of the angles here on the x-axis for us, positive angles and negative angles. But the y-axis, the scale isn't labeled, so let me go ahead and do that. And I'm going to say 2 tick marks is going to be 1 unit. So if I go down 2 tick marks, that's where negative 1 is. Okay. All right, so now if I plot some points, when x is 0, my output, my y value is going to be also 0. So I'm plotting the point 0, 0. And then when x is pi over 2, the y value is 1. So that is here, pi over 2, 1. When x is pi, the y value is 0. That's here. And then 3 pi over 2, negative 1 would be over here. Finally, 2 pi, 0, that is there. So if I connect these points and I start to draw my graph, I'm getting something like this. It goes up, then it goes down, and then it comes to this low point, then it starts to rise again. So I'm getting this. And, you know, I could keep going like this. If I were to go more than one full time around the unit circle, what would happen is I would start to cycle through all the same y values again and again and again. And in the graph, what happens then is the graph starts to repeat this shape where it goes up. It reaches that high point at the y value of 1. And then it goes down, and then it keeps oscillating up and down like this. The same thing happens at these negative angles. So I'm going to go ahead and plot some points on that side as well. So when x is negative pi over 2, when my angle is negative pi over 2, the y value is negative 1. At negative pi, the y value is 0. At negative 3 pi over 2, it turns out we come up here back up to 1. And then, whoops, sorry. And then at negative 2 pi, the y value is 0. So continuing that graph, it goes down here, then it comes back up to my x-axis, then it rises to this high point, then it starts to drop. Ooh, let me draw that better. Then it starts to drop, and then it'll keep oscillating. It'll keep this up and down shape going. All right, so the domain of my graph is just negative infinity to positive infinity. The angle that I plug in could be anything. The range of my graph, the y values, well, the lowest y value is down at negative 1, and the highest y value is up at 1. So negative 1 to 1, and I do achieve both of those y values, so I put brackets. And now I'm going to introduce a new term, which you likely would have seen at some point in precalculus before, if you've taken precalculus before. Period. Period is how long the graph takes to repeat. So how far do you have to travel in the x direction before it starts to repeat the same shape? So like, for example, if I'm starting at the x value 0, I go up and down and then here. And then once I'm at 2 pi, now it's starting that same shape that I was starting at 0, where it goes up and then down. So every 2 pi, this thing repeats. So that is the period here. All right. So that is the graph of sine x. All right. So now next up, I want to try cosine. I want to do the same thing. Plug in some points to get a feel for what the graph of y equals cosine x will look like. And then I want to do the same thing for the graph of y equals tangent x. Okay, and I'm realizing there's one other thing I wanted to mention, which is the symmetry. So let me go back and do that. So the symmetry of this graph. So this graph is symmetric about the origin. And remember what that meant was if I took any point on the graph, like over here, and then I draw the mirror image of it across the origin, so I draw a dotted line, mirror image of it across the origin, go the same length in the opposite direction, that I get another point on the graph. So that's going to happen no matter which point I take. No matter which point I take, if I reflect it through the origin, I get another point on the graph. So this graph exhibits some symmetry across the origin. Alrighty, so next up I want to think about the graph of y equals cosine x and the graph of y equals tangent x. So I'm going to give you some time to try these. With tangent x, it's also going to be helpful to plug in a few more x values, a few more angles. I would also recommend plugging in pi over 4, as well as negative pi over 4. So also plug in those angles for tangent. All right, so what I want to do now is give you all some time to try these. So take about 3 minutes for cosine to plug these in, plot those points, and draw the shape of the graph. And then do the same thing for tangent. Take 3 minutes to plot these points, and then draw the graph of tangent once you have them. All right, pause it in 4, 3, 2, 1, pause it, and draw both of these graphs of cosine and tangent. This is great practice using the unit circle and evaluating trig functions. All right, so hopefully did that. Hopefully plotted some points here, and maybe we're getting somewhere along the road of drawing the graphs. All right, so let's talk about cosine. When my angle's 0, and I plug that in to get cosine of 0, well, remember, cosine is my x-coordinate. So if I look at where the angle 0 is, my x-coordinate is 1. Okay, so I'm going to put 1 in my table. So cosine of 0 is 1. At pi over 2, the x-coordinate is 0. At pi, the x-coordinate is negative 1. Let's draw that better, negative 1. At 3 pi over 2, the x-coordinate is 0. And then at 2 pi, the x-coordinate is 1 again. Okay, so if I take these values and plot them, again, I'm going to make 2 tick marks on the y-axis be 1, and 2 tick marks down be negative 1. And if I plot these points, now when x is 0, the y value is 1. So my graph now is starting up here rather than at the origin. And when x is pi over 2, the y value is 0. Okay, When x is pi over 2, the y value is 0. When x is pi, y is negative 1. When x is 3 pi over 2, y is 0. And when x is 2 pi, the y value is 1. Okay. And if I were to connect these points, the graph starts to go down, keeps going down, reaches this low point, and then it switches course, goes up, reaches this high point. If I were to keep plugging in bigger angles now, and if I were to go around the unit circle again, well, I keep encountering the same x values again and again and again. So the graph is going to have the same shape. It's going to keep oscillating like this and repeating the same shape. The same thing happens if on the negative side. I'm going to plot a few points though. So it goes through negative pi over 2 comma 0, negative pi comma negative 1, negative 3 pi over 2, 0, and then negative 2 pi comma 1. And if I connect the graph going this way, it goes down, reaches this low point, then it goes up, has this x-intercept, goes up, reaches this high point, and then it keeps oscillating like that, up and down and up and down. So my domain here is also negative infinity to infinity. The range, well, the smallest the y ever gets is negative 1, bracket, because I do reach that y value. And then up until 1, bracket, I do reach that y value. The period, well, how long does this graph take before it repeats? Well, again, I go, this far along the graph, and then it'll start to repeat that same shape. It starts to repeat that same shape. So I've gone, how far? I've gone 2 pi. I have gone 2 pi in this x direction before it starts to repeat its shape. So the period is still 2 pi. And then what type of symmetry does this graph have? So symmetry. Well, this graph is symmetric about the y-axis. Symmetric about the y-axis. If I take any point, if I take the graph on the right-hand side of the y-axis and I reflect it to the other side, it gets the other part of the graph on the other side of the y-axis. So this graph is the mirror image of itself across the y-axis. Okay, finally, we wanted to draw the graph of tangent. This one's a bit more interesting. It looks more different than just the graph of sine or cosine, which keep having this up, down shape. So with the graph of tangent, if I plug in 0, and I work out what tangent of 0 is, well, I know tangent is y over x. Tangent is y over x. And where the angle 0 is, which is here, if I take the y coordinate and I divide it by the x coordinate, I'll get 0 over 1. I'll get 0 over 1. 0 over, which is 0. Okay, awesome. What about at pi over 2? At pi over 2, if I do y divided by x, y divided by x up here will give me 1 divided by 0. So at pi over 2, I'm going to be doing 1 divided by 0. But I can't divide by 0. That's undefined. Okay, so that's a bummer. What about at pi? At pi, if I do y divided by x, I'm going to do 0 divided by negative 1. So 0 divided by negative 1. 0 divided by negative 1, and that is 0. Okay. At 3 pi over 2, this bottom angle, doing y divided by x, gives me negative 1 divided by 0. So negative 1 divided by 0. That is also undefined. I can't divide by 0. 2 pi, that's the same spot on the unit circle that 0 is at. So the output is going to be 0 for that. Tangent of 2 pi is also going to be 0. If I were to just plot these points right now, let me put some tick marks on the y-axis. Let's say that this is 1 and this is negative 1. Okay, well, when x is 0, the y value is 0. So that's here. When x is pi, the y value is 0. And then when x is 2 pi, the y value is 0. That's just not a whole lot to go off of. And that's why I suggested plugging in a couple of other points. So if I use the angle pi over 4 and negative pi over 4 on my unit circle, so if I use those angles, so pi over 4, remember, is 45 degrees. That is over here, the angle pi over 4. Okay, and the angle negative pi over 4, that's, going 45 degrees. But in the clockwise direction. Negative pi over 4 would be down here, negative 45 degrees. We'll recall what the coordinates were at the unit circle at those points. At pi over 4, it's x is root 2 over 2, and y is the same, root 2 over 2. And then down here where negative pi over 4 is, my x coordinate's still positive, still root 2 over 2. But the y coordinate is going to be the same value, but it's negative because I'm down here where the y values are negative. So comma, I'll put a negative root 2 over 2. Okay, so if I take pi over 4 and I do y divided by x, well, those are just going to cancel and it's going to give me 1. So tangent of pi over 4 is just 1. Okay, what about at negative pi over 4? At negative pi over 4, if I do the y value divided by the x value, well, this negative will still be lingering, so I end up getting negative 1. So if I plot these points as well to get some more information, when x is pi over 4, y is 1. So pi over 4 is here, halfway to pi over 2. And at that x coordinate, the output I'm getting is 1. All right. And when x is negative pi over 4, the y value is negative 1. That would be here. So I'm getting a little bit more information. What's going on at these points like pi over 2 and 3 pi over 2 where it's undefined? At those points, the graph has a vertical asymptote. So I'm going to draw those in. So at pi over 2, there's a vertical asymptote. I'm going to draw that in. Same thing at 3 pi over 2. If I keep going like this, it'll also happen at negative pi over 2. It'll also happen at negative 3 pi over 2. Those are all going to be spots where when I do my y divided by x, my denominator ends up being 0, and it makes the whole thing undefined. Okay, so now if I connect these points, keeping in mind that there's asymptotes over here on the sides, it's going to create a graph that looks something like, and it kind of curves, it snuggles up next to the asymptote, and then it curves this way, and then it snuggles up next to the asymptote. It's going to have that same shape between each pair of these asymptotes. So here as well, it's going to curve up, snuggle up next to the asymptote. Here it's going to curve down, snuggle up next to the asymptote. Okay, same thing here. Curve up, snuggle up next to the asymptote, curve down, snuggle up next to the asymptote. All right, and it keeps repeating that shape. It'll keep repeating that shape. So even here as well, snuggle up next to the, let me draw that better. Going down, snuggle up next to the asymptote, and then going up, it'll snuggle up next to this asymptote, and it keeps repeating like this. Okay, so for this graph, my graph of tangent x, I get this. All right. So my range, I think that it's easier to state the range than the domain. The range, the y values they could go be as negative as I want. They could also be as positive as I want. So the range is just negative infinity to positive infinity. How long does it take before it repeats? Well, it repeats between each pair of asymptotes, and that's a length of pi. Going from pi over 2 to 3 pi over 2, I'm adding pi to it. So the period is pi. Before I get to domain, what's the symmetry? What type of symmetry does this graph have? Well, the symmetry is about the origin. Right, if I take any point on the graph, like this one, the mirror image of it across the origin is also another point on the graph. So it's symmetric about the origin. Okay, and then what's the domain? Well, it's a bit trickier to write in interval notation because I'm going to need infinitely many intervals for this. So instead, I'm going to write it in words. The domain is all reals except these places where I have asymptotes. And those are places like all reals except we get plus or minus pi over 2, plus or minus 3 pi over 2, comma, plus or minus 5 pi over 2. And at this point, we see the pattern. It keeps going like this. I'll just put comma, dot, dot, dot. And that is my domain right there. Okay, and that is our graph of tangent. Okay, so if you've taken precalculus before, you might recall these graphs. You might have seen these before. But whenever we're unsure about what these graphs on what they look like, we could just plot some points to quickly get them. In fact, it's really good practice using our unit circle to get these. The graphs of sine, cosine, and tangent are definitely the most commonly used, the ones that show up most often. The other three trig functions, I've gone ahead and just graphed them for us. But if we ever needed these graphs, I honestly wouldn't try to memorize these. I would just know how we can get them. We can get them by plugging in some nice values for the angles, plotting some points, and then plotting the graph from there, just like we did in these examples. And there we have it for the graphs.